Hello everyone, my name is Gaurav and today we shall be discussing about Young's double slit experiment. So the experiment setup will be like this. We have two slits, small slits S1 and S2 having a gap of, let us assume, D. The space between these two slits is D, and we will be incidenting some light source here, and a lens we will put here so that we will get parallel rays of light going through S1 and S2. So what shall we expect on the screen, that which we will put, let us assume, at a distance capital D, and D is much greater than small d. Okay, so as per our expectation, from this slit light will go here, there will be a bright spot, here there will be a bright spot, and whole here there will be dark, as we have a opaque kind of thing over here. So here there will be dark spot, but the real story doesn't go like this. What we observed is, what Young's uncle observed is that here there was a central bright, then there was a dark spot, then there was bright, again dark, bright, again dark. Like this, fringes were formed after a central bright. Okay, fringes were formed at a distance, let us assume y, x, z, whatever distances. Dark, bright, alternating bright and dark bands were formed basically. So what is the reason for this is, we explain it as that light is a wave, so there will be wave interaction basically. Okay, so if light is a wave, from the chapter wave, class 11th, what we know is we can write the equation of a wave as sine omega t minus kx, any wave, a naught sine, let us assume y as a function of x and t, a naught sine omega t minus kx. So what we are telling is, this y, this y, how much the wave is, as a function of x and t, means what is the on the x-axis, about which point am I telling? Let us assume this is x, and at a time t, the particle over here is oscillating like this, kada? It is oscillating like this. So at time t, I have captured a photo, and the particle is here at this time. Okay, so y distance, what is the distance from the baseline as a function of displacement x and a time t? The expression of a wave is given as a naught sine omega t minus kx, where a naught is the amplitude, basically this one, a naught. Okay, so we know that waves interact with each other according to their phase differences. If both the waves have a phase difference of 0 or pi, or 2 pi, 3 pi, 4 pi, in the multiples of pi, if the phase difference is there, then they will have constructive interference. And if the phase difference is pi by 2, then there will be destructive interference. See, what I can write is, if there is another wave, let us assume this is y1, and there is another wave y2, which is a naught sine omega t minus kx2, let us assume, and this is kx1. What I mean to tell is, this is a wave, okay, omega t. What am I trying to tell when I am telling omega is the same for both the waves is that I am telling the source of the wave is common. They have the same frequency. Okay, they have the same frequency. So I captured a photo of the wave. Okay, and this is the photo. So at x1 and x2, let us assume this is x1 and this is x2. Okay, this is x2. This is x2. At x2, y is this one, and the motion of this particle will be like this. and the motion of this particle at x1 will be like this, isn't it? It might be coming down there. So you can see there is a phase difference. Phase is nothing but, take the meaning literally as phase means in what condition or what it is going to do, what that particle is going to do. That is the phase of that particle. This particle phase is in this direction, that particle phase is in that direction. So basically there is a phase difference, and if this is the phase of this part, this y2, this is the phase, and for y1 this is the phase. If I will write phase difference delta phi, it will be omega t will be cancelled out, so it will be k delta x. Okay, k delta x, and delta x is this x1 x2 minus x1, k delta x, and k we know that k is 2 pi by lambda. Okay, this we need to remember from this waves. Now again going back to the Young's double slit experiment, here similar thing is happening. This is slit S1, this is S2 basically, S2. We have a screen over here, okay, and this is, let us assume, distance y. So we will find that what is the distance y at which we will get first bright spot, that bright dark, bright dark, bright dark we were getting from the central bright, at what distance y we will get the first bright spot. We will find that out. So wherever bright spot is getting formed, there constructive interference of waves are taking place. So that delta x path difference, from where this path difference is coming, whatever, so the path difference is coming now, it should be equal to pi or 2 pi or 3 pi. Basically the phase difference between those paths should be pi, 2 pi, 3 pi. What I mean to tell is, again just I want to tell, if this is a wave and this is another wave, if these both will interact, there will be a constructive interference. And what is the phase difference between these two paths? It is 0 as of now. And let us extend this wave. Okay. So if I bring this part here, okay, so this part is 2 pi phase ahead of this thing, okay, and if I just want to fit it here, they will fit perfectly actually, although it is 2 pi phase ahead of this, okay. So there will again be constructive interference. So n pi locations, n pi, whenever the phase difference is n pi between two waves, there will be constructive interference. But if, let us assume, I will bring this here, just here, not here. So what it will be like this. When these two things will interact, there will be destructive interference. Basically these both will cancel out each other. At what phase differences? It will be pi by 2 or 3 pi by 2, 5 pi by 2, basically n plus 1 and n plus pi by 2. N plus pi by 2. Okay. N plus 1 whole into pi by 2. Isn't it? So it is like, if we'll assume n as 1, no. What can we write the general formula? Like pi by 2, 3 pi by 2, 5 pi by 2. So this is n plus 1 by 2 pi by 2. If n we will put 0, n we will put 0, n will put 1, then it will be this will be the general formula. Okay, this will be the general formula. So again we'll go to calculations. So we need to find a distance y at which there will be formation of first bright spot. Okay, so light ray will travel here and from here it will travel here. So what is the path difference? Means light from S1, it is going this much distance, from here it is going this much distance. So if I draw perpendicular over here, these distances are same, this and this is same. The extra distance is this one, let us assume this is delta x. Okay, this we have distances between slit is d, this is theta, let us assume. So sine theta, applying all those things, this delta x will be d sine theta. Okay, remember this. Now see, if this is theta, this is 90, this will be 90 minus theta. Okay, this will be 90 minus theta, this is 90, so again this will be theta. Okay, if this is theta, if that is theta, then this is also theta. Okay, because we will assume that this and this are parallel lines, because the setup is very, d is much greater than small d. This is very large distance, this is very small. If this is very small, almost everything will be parallel only. Okay, so this is also theta. Now here if I will put tan theta equals to y by d. Okay, if theta is very small, tan theta will be sine theta. Okay, tan theta will be sine theta. From here, sine theta is delta x by d. So I can write delta x by small d equals to y by capital D, or else I can write delta x equals to y small d by capital D, yd by d. Sine theta, tan theta equals to y by d. Or I can write, don't remember it in this way, remember that we need so what we were going to find, the distance the distance y at which first bracket will be found. So y is coming as delta x capital D by small d. Okay, and delta x, when this path difference will be lambda, 2 lambda, 3 lambda, 4 lambda. Okay, when the path difference, this, see, either the path difference will be 0, there will be constructed interference. If the path difference shifts by lambda, okay, again, if the path difference shifts by lambda, again there will be constructive interference only. Somewhere in the, somewhere at this point there will be constructive. If it is 2 lambda, 3 lambda, 4 lambda, 5 lambda, 6 lambda, there will be constructive interference. Okay, so delta x for bright will be n lambda, and here d by d, y equals to n lambda d by d. If we will put n as 1 for the first bright spot, we will get as y equals to lambda d by d. This is